Good evening, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and all-around meteorologist, as well as secret member of the Society of Evil Scientists, DT, from weatherist.com, your commander of chaos, Colonel Confusion, Captain Catastrophe. We got a nor'easter to talk about. Yeah, the first one of the season coming up here for this weekend. Some model confusion, a lot of model uncertainty, but things are beginning to come on more clear. So we'll be talking about this nor'easter specifically this weekend and what it means, the timing. So if you pay attention to this video, a lot of you have questions about the timing and when this is going to take place. What about your outdoor plans? Just watch the whole video, and one of the great things about the video is that you get to stop it and watch it over and over again if it's something you don't understand. In any event, so this is, of course, it's a Monday evening, October 22nd, star date 201810.22. Starting this video at 8 o'clock. It's probably about 10 p.m. now by the time I get it done. So, and by the way, that's Star Trek time. For those of you that do not use Star Trek time, you're all losers. I just want you to know that, okay? There you go. All right, so there's a picture of my smiling face, how you can reach me there. Gmail, my two Twitter accounts here, and really for operational weather forecasting in terms of like snowstorms on the East Coast or winter weather, you want to focus on that one. This one is mostly for my grain trading. Comments about winter wheat crop for the U.S., for Brazil, for Argentina, for Australia, China, what have you, that sort of thing. So, like I said, you really want to focus on this one. And of course, there's the Facebook page. All right, let's go on to it now. Next, I want to talk about here the different types of East Coast lows. There are essentially three different types of East Coast low pressure areas. So, and I'm going to be using this definition all throughout the cold season here, from now all the way into like April when we get through the cold season. Now, you may not agree with these definitions, and that's fine. But for my purposes, and so that I can convey the information to you, whether or not you agree with these definitions, I'm going to use them so that way you have a reference to what I'm referring to. So, on an inland track here is obviously when the main low tracks west of the coast, usually west of Interstate 95, once it moves north of the South Carolina, North Carolina border. Essentially Charlotte to Wilmington. Once it moves north of that line, then you can determine whether it's an inland track or not. A coastal low track, obviously, this one here, refers to the track along the coast, usually within 50 miles to the west or east, once the low reaches north of the North Carolina-South Carolina border. It may be just offshore on the coast, just inland, but that's a coastal low. And then the nor'easter, when a lot of things get cold nor'easters and they are not, is the low when it tracks offshore, usually, not always, 75 to about 250 miles offshore. Now, the problem here with that definition, of course, is New England. So let me show you what I mean by that. Because of the New England coast. Now, obviously, this here is the northeast quadrant of the U.S. This is about what we call the northeast quadrant. 25% of the U.S. northeast side. So you can see, obviously, all the way down here, this is your South Carolina border here, down in here. Okay, so the South Carolina, and over here is Ohio. So this is essentially the northeast quadrant. Now, notice how the New England coast. This is 75 degrees longitude right here. This is the point which hits Hatteras and goes up to Philadelphia. Okay? Notice that New England all sticks out to the east. Now, this is one of the reasons why New England gets more snow than a lot of places. One, because it's a little further north, but more importantly, because the whole coast sticks out like a giant chin. So New England gets more snowstorms and heavier snow. So if the coastal storm is giving you in this area, in Philly or DC, Baltimore, 6 to 8, 10 hours of snow, New England, because it sticks out like this, could get a lot more snow. That's the first thing. The second thing is that the low could track a coastal low. So it could track off here. Okay, that's a nor'easter. That's a nor'easter. But what about here? It's all very close to Cape Cod. Well, again, because New England is the exception here, it sticks out like that. We have to go with the general rule. So even if it passes close to Cape Cod, it's still a nor'easter. So I just want to clear that point up for you for clarification. All right, let's take a look at this system here. Now, yesterday I posted on the DTVA weather Twitter account that the Sunday GFS was completely losing its mind, had all sorts of wacky, goofy-ass solutions. And I posted this earlier and on the Facebook page, so you can see it. So this was the Sunday GFS, all right? So this was yesterday's. This was Sundays. Now the problem is, as you can see, it's got two pieces of energy. One piece of energy here, one piece of energy there, and then that continued. Again, very strong piece of energy, and as a result, the GFS has had two areas of low pressure, which is just not going to happen. One of those features will die out, and the other one will take over. So usually it's the lead feature which dies out, and this one takes over. So that's what the GFS is doing, and it was a viable solution. Now here was the even the 18Z GFS was doing the same sort of thing. It had two strong pieces of energy. You can see them circled here in blue. Let me highlight it so you can see what I'm talking about. This piece of energy and this piece of energy. And again, this resulted in two areas of low pressure. This is a little better because here you have one main low right here and then a secondary low of Chicago. So maybe the GFS is beginning to catch onto it a little bit. Okay, so that was good. Now here is the European model. Now this was the European model from Sunday, Sunday afternoon again. So this is a Sunday's run here. Oops. Sunday 12Z. And you can see the European, look where the European takes the low. Over the Delmarva. And then inland, up into Jersey and New York City. Now what that does is that creates a big push of rain, but then you get a dry slot in here. Okay, where not much is happening. All the precip is to the northwest, the north, and the northeast side. And then, of course, the cold front's like this, and then the dry slot pushes all the way up to New York City, Connecticut, so on and so forth. And back in here, the northwest side, is where you get your big precipitation. So, and this is why the placement, the track of the surface low is so important. And one of the reasons why a lot of forecasts for coastal storms run into problems. Hey, Mr. Weatherman, you promised me 6 inches of snow or 2 inches of rain. I only got a half inch. Or only got 3. What happened? One of the reasons is because the forecasters don't overlook the dry slot thing. This whole they overlook it significantly. They really do. And that cuts down the precipitation. So if the low is out here, now let's take a look at this 1 second. See how the precip is to the northwest of the low? See how the big precip is here and here? So if we put the low out here off coast, guess what every precip is? Over I-95 big cities. If the low is out here, it's in New England and New York City, New Jersey. But because the low is on the coast, the dry slot comes in and you get a totally different forecast in terms of how much precipitation. And all the precip is over the mountains of Northwest Virginia, Western Maryland, Pennsylvania, Central Maryland, that sort of thing. Now, some folks are looking at this also wondering whether there might be some snow in the mountains, and I don't think that's going to be the case. We'll get to that in a second. All right. Now, this is something which I've showed from time to time, and eventually, as we get into the winter, I'm going to show this entire a whole video simply about these four main teleconnections. What are teleconnections? It's a fancy weather term. It means a specific type of weather pattern in the jet stream. So these four features, these big four, are help determine the winter patterns, and to some degree the summer patterns. Really, autumn, winter, and spring, and to some degree the summer patterns. So let's take a look at them briefly without getting too scientifically. I don't want to overwhelm you too much science here. So the basic guide to this, all right, the four teleconnections. The EPO, which is this one. Let me get my marker out so you can see it. Right here, we're talking about that one, okay? Now, the EPO it stands for Eastern Pacific Oscillation. It measures the size and the intensity of the ridge over northwest Canada. It is ideal for winter storms in the eastern U.S. The ideal would be to have a negative EPO, not a positive, a negative EPO. When the EPO is negative, it establishes a Siberian cross-polar flow. So it's not just cold air coming out of Canada, you're now getting Arctic air coming out of the Arctic region and Siberia when the EPO is negative. Okay, when the EPO is negative. Let me change markers here so we can see this a little better. Good. When the EPO is negative. Now the Pacific, the P&A pattern, that stands for Pacific North America, and that refers to this pattern right in here. Right there. Okay. So what does that mean? Well, now the P&A pattern refers to the ridge in the jet stream, a mountain of air, a bulge, which develops over west coast of the United States and Canada. So you'll see the ridge, the meteorologist talking about a ridge extending from California up to northwest Canada. When the P&A is positive, it allows Canadian cold air to move more directly into the central and eastern U.S. And it increases the chances of the northern jet stream and the southern jet stream merging and having a party on the east coast. That we call that phasing in the weather business. Okay? Good. Next, the Arctic Oscillation. What does that refer to? Okay, well, let's take a look. The Arctic Oscillation here is this thing to the north, as you can see, and it refers to a very, very important feature, which is a big determining factor. And it's called the Arctic Oscillation. Now, the size and the intensity of the Arctic Oscillation is connected to the polar vortex. They're very much related to the same sort of thing. When the Arctic Oscillation is weak, it's in the negative phase, and you want that for East Coast winter storms. This makes it easier for the Arctic air to come southward into the continental U.S. So the Arctic Oscillation is generally negative. Sustained long-term Arctic Oscillation weather patterns that are negative almost always mean prolonged colder than normal weather patterns. Sometimes you can have a winter where it flips back and forth for only for a week or two. It's a week, 2 weeks of cold, 2 weeks of mild, 2 weeks of cold, 2 weeks of mild. Sometimes you can have it consistently mild, then it flips to the middle of the winter and becomes positive. And you get a cold pattern followed by a mild pattern. So there's all different possibilities, but that's what the Arctic Oscillation does when it comes to winter storms on the East Coast. And then finally, there's the NAO, the North American Oscillation, and that refers to this over here in the upper right corner over eastern Canada and Greenland, right here, that feature. Now, what does that refer to? What does it mean? Well, it's also known as the Greenland Block, and it measures the jet stream pattern over eastern Canada and Greenland and Iceland versus the jet stream pattern in the Atlantic Ocean. Now, ideally, for an East Coast winter storm or nor'easter, you want to have the NAO run in the negative phase, which keeps the trough over the eastern U.S. A negative NAO keeps low pressure areas when they come out of Texas so they don't go to Chicago. When the NAO is negative, generally, it keeps it along the East Coast or just off the East Coast. Sometimes, as you know, you look at a storm in Texas, you go, man, that's going to hit us, and then it goes up to Chicago or Michigan or Cleveland, you go, and the snow goes over the rain on the East Coast. That's because the NAO might not be negative. It might be positive. So that's why the NAO is positive. So these are all 4 different things you need to take a look at. Now, if we take a look at the actual data, okay, this is from a weather bell here, and you can see the European ensemble showing quite nicely that the Arctic Oscillation right here, 25, 26, 27, this is the neutral line. See how it dips down here just when we get the East Coast storm? Here's the NAO, and you can see, actually this, repeat, hang on one second. Okay, I corrected it for the correct NAO. And here with the NAO on the European ensemble, again, we can see it dips down briefly right here. And then, again, we're looking at the green, which is the ensemble mean, not the black. Look at the green. So you can see the dip down in here. And then the NAO, which is now positive, dips down slightly negative, and then back almost to neutral after we go to the beginning of November. So again, both of these features go negative as we're trying to get this coastal storm. So that's pretty good. Now, on the western side of things, let's look at the EPO and the PNA pattern. Remember, the EPO is the original Alaska. We want it to be negative. Now, right now, as you can see, it's negative, and then it goes positive, as you can see up in here a little bit, and then it drops down again. So you can see that it does turn negative as we get to the storm by the weekend. And then here is the PNA pattern. Here it's strongly positive, going into the storm, drips, and then and stays generally positive past the storm, right past the beginning of the month. And then by the early November, it goes to neutral. So all these factors are favorable for some sort of East Coast winter storm. So that's good. Now, setting this up as the event beforehand, there's another reinforcing cold front that this is Tuesday night, Wednesday morning. And what happens is you can see this big upper low which forms right here. You see this northwest flow bringing the cold air in? That's the big high here, okay? And it brings the cold air in, and you can see this is very cold air. This is easily as cold Wednesday morning. Thursday morning will probably be as cold as what we saw this morning on this Monday morning over the Mid-Atlantic, the Great Lakes, and New England. It's going to be a pretty cold one. And there's a southern piece of energy. Now, the dashed lines here over Texas, this refers to the developing southern system. And we'll get to that in a second. So, but that's how the setup. Now, if we look at this on hemispherically, we can see a large-scale feature of how these patterns are shaping up. So here we have a little bit of a ridge right here over Greenland. So that's kind of a negative NAO right here. Kind of. Okay. Then we have a negative Arctic oscillation. There's no big low here, so we have a negative Arctic oscillation. That's good. A little bit of ridge on the west coast, and there's our system beginning to develop in the jet stream right here on Friday morning. If we look at that in more detail, we can see it even more detail here. So we have this system right here. And notice that it is neutrally tilted over the Mississippi River, which is a good sign. You don't want it tilted. You want it tilted over the Mississippi River when it gets there. The piece of energy in the jet stream, you want the alignment to be straight north to south by the time it gets to the Mississippi River. If it goes negative too early, let's say if it does something like this, then you're going to get a low forming here. I go up the Appalachian, so that doesn't happen. So that's a good sign. Then as we go into a Saturday evening, again, we can see that the features are changing. Now the ridge over Greenland is breaking down. It looks weaker. It goes over to Iceland, so that's not very good. The ridge is still here on the west coast, and this big trough is now forming over the eastern U.S. as the storm begins to develop. So it's a decent looking upper air pattern. It's not ideal. And if we look at it, here's the European 144 hours. Now look what happens here. Notice, see the tilt on this thing? See the alignment like this? Okay, that's a negative tilt, what we call a negative tilt. And what that means is that the low pressure areas here is going to get pulled inland. What you want to see ideally is you want to see the negative tilt not there. You want to see it, hang on, let me change markers here. You want to see the negative tilt this way. This is too far to the northwest, and the low on over the Georgia is going to get pulled along the coast. It's just a tad too far too soon, and that's going to be a problem. Now here we can see this in some. Here's the GFS, the improved FV3 GFS, and you can see does the same sort of thing. This is the 12Z run today, so this is 12Z on Monday. Okay, this is the Monday run. You can see the low here Friday morning. The rain is right here in North Carolina. The cold high is beginning to break down, and there's the low goes to by Friday night goes to the Carolina coast, and then by Saturday morning it's off the Virginia coast, the Delmarva, and then it's off the southeast coast of New England by Saturday night. So it's not a huge monster storm. It's not the worst nor'easter of all time, but it's a coastal storm. Now you can make the case that this is a nor'easter. You could make that case. On the GFS, it's a nor'easter, but I'm not sure that's going to be correct. Now this is the European model also. This is from 12Z today. So this is Monday's European model. Notice the lows here, then it's along the coast, and then look what it does. It goes into New York City. It gets pulled northward because of this upper low here, and because the European model has that solution. It pulls the coastal low inland. So the European is not a nor'easter. It's a coastal low. Now we take a look at the sequence of events here. So down here on the bottom on the European, this is Friday, 8 p.m. You can see the low right here. And then this is a Saturday, 8 a.m. and the rain's now moved to New York City. Notice very little snow in the mountains here, not a lot. And then the final we have here. This is Sunday at 2 in the morning, and then this is this one here is Saturday night, and then this is early Sunday morning. And again, look what the low is. It's not off the look. It's inland. It is. I'm sorry. It's over the Delmarva, and then it's over Allentown or New Jersey. That's not a nor'easter if the European model solution is correct. Now, I'm not saying the European is correct. I think it will be, but the European model, if you assume that, it's not a nor'easter. All right, and now here is the GFS. Now this was the 12Z GFS from this afternoon. And again, remember how we talked about it's off the coast, it's a nor'easter. Okay, fine. This is the 12Z run. Shoot, this is the 12Z run. Okay, valid 2 o'clock in the morning on Sunday. Now, look what the updated run, the 18Z run looks like. Same time frame, 2 a.m. Sunday morning. This is 18Z. See where the low is? On the Jersey coast. Big difference. Huge shift to the west. This is a trend is telling me the European's correct, folks. That's what this is telling me. So we had this, now we have that. We had this, now we have that. That's a shift west. Okay, here's the rainfall on the European. Look where the heaviest rain is, inland. Heavy precipitation. In fact, look at Norfolk and North Carolina in here. They don't see much of anything. How about that? Yeah. And all the big stuff is out here in the Shenandoah Valley, eastern West Virginia, that sort of stuff. Central Maryland, southwest Pennsylvania, Altoona, that sort of stuff. And then if we go to the GFS, the F3, FV3, the improved high resolution GFS. Again, this is the FV3. Notice it has the best rains up over here as well. A little bit of a dry slot down here, but definitely more in tune to the European model solution. And if you compare the last few runs of the GFS, and this is why I do not use the GFS for East Coast storms beyond 84 hours. Look at the shift in the precipitation. This was early this morning, 6Z GFS. All the precip, look where it is. Nothing in DC, nothing in Philly, nothing in New York City. All of it's down here. Okay? Then 6 hours later, oh, look. Now the heavy precip isn't getting up into Southeast Virginia and Richmond and North Carolina, and it's getting moderate precip into Charlottesville and Baltimore and DC and Philly. And then look, this is the 18Z run. Oh, I'm sorry. Look how long it took to go this. This is the 18Z run. I like this a lot. I think this is correct. Okay, and look where that's the regular GFS, right? And then look where the FV3 was. See? And then, of course, here's the European. Now, here the GFS is simply arguing the heaviest precipitation is to the southeast of the European, but it's definitely trending northwest. You can clearly see it. 6Z, 12Z, 18Z, all regular GFS. All right, timing. Here we go, boys and girls. Pay attention to the timing. Here it comes. It's Friday morning. There's not much rain. There's a little bit of rain in southwest Virginia, not much going on. All the rain is generally just to the south and west of Raleigh and Greensboro, and then in Kentucky. Big, moderate, heavy rain down here, Tennessee, southwest, North Carolina, Greensville, Spartanburg, Asheville, Atlanta, that sort of thing. Okay, that's Friday, 8 a.m. Now this is Friday, 2 p.m. Friday, 2 p.m. Now the rain line has reached Richmond and Charlottesville and into southern portions of West Virginia. Not raining in DC, Baltimore yet. Okay, and this is Friday, 8 p.m. Okay, look at the heavy moderate rain. Richmond, Charlottesville, Roanoke, Lynchburg, Greensboro, Raleigh, Winston-Salem, Charlotte, Beckley, Bluefield, Elkton, Greenbrier, Charleston, West Virginia, all of it getting hammered with significant rain. Now the black line shows the edge of the rain line. So the 8 o'clock Friday, the rain just getting into Northern Virginia, DC, probably reaching Salisbury, Maryland, up towards Pittsburgh, 8 p.m. Okay? There you go. Now, what's next after that? This is a Saturday. Here we go. Saturday, 2 a.m. Saturday at 2 a.m. and this is Saturday, 8 a.m. So 2 a.m. it's raining like hell in most of Virginia. Southwest Virginia, the rain has ended. You know, out west of I-77, the rain has ended. But Roanoke is heavy rain. Lynchburg, Hot Springs, Beckley, Bluefield, Charlottesville, Lynchburg, Richmond, Danville, Martinsville, Culpeper, Warrenton, the entire Piedmont, all of DC Metro, all Baltimore Metro, Western Maryland, Gettysburg, Harrisburg, Lancaster, up towards Baltimore. Most of the Delmarva has moderate to heavy rain. Now, the other thing is, look at the dry slot. Remember I talked about that earlier? The model is clearly showing the dry slot punching in here towards Southeast Virginia. Now, Saturday, 8 a.m., if you've got plans Saturday morning in Hampton Roads, you might not be in bad shape. If you have a wedding to go to, if you've got whatever your plans are, any sort of outdoor activities, what have you, you're going to Williamsburg, it might not be that bad Saturday afternoon. The dry slot is clearly punching in to Hampton Roads and eastern North Carolina by Saturday, 8 a.m. Okay. Meanwhile, Richmond still has moderate rain. DC has moderate rain. Winchester, Hagerstown, Frederick, Charlottesville, still rain all the way back to Lynchburg and Roanoke. Okay. And finally, here is Saturday at 2 p.m. in the upper left corner. Saturday, 2 p.m. Look at this. Dry slot completely, all the way up into southern New Jersey. Again, this means, I'm not saying it's going to be completely dry in Hampton Roads, but I don't think it's going to be a washout in Hampton Roads. I don't. I think the dry slot's going to come in. As long as this low comes inland, so if you're in Salisbury Saturday afternoon, Wallops Island, like Melfa, Accomack, the southern port and Chesapeake Bay, most of Hampton Roads, East North Carolina, the Outer Banks, Elizabeth City, you might be okay Saturday afternoon. Might be a horrible day. So, not going to be sunny and warm, but not horrible. Okay. Meanwhile, still raining in Richmond and most of Virginia Piedmont up into D.C., eastern Virginia Panhandle, western Central Maryland, all of Pennsylvania, so on and so forth. The rain has stopped in most of North Carolina at this point, no doubt about that. And then Saturday at 8 p.m. here, this is 8 p.m. at the bottom, the rain is still going Central Virginia down to D.C., Northern Virginia, pretty much stopped by Richmond in the evening, and then again, all this is drying here and drying here and drying here. So I just wanted to point out to you that's the sequence of events. Okay. Because I'm going to ask that question a billion times. All right, and then finally, what happens after this? Okay, at the beginning of November, the pattern shifts a little bit. We get a bit of a trough forming here, and that means low pressure areas coming out of here and tracking in this direction. Okay, so just to go back to your pattern here, this having a trough like this. Now you do have a ridge on the west coast, so that's good. Okay. But when you have this is not. Notice you do not have a negative NAO here. The NAO is positive. Okay, the Arctic Oscillation is probably neutral, but you do have a ridge on the west coast. So this is trough here in the Rockies. That's going to produce low pressure tracking up through the Midwest and the Great Lakes in northern New England. So the pattern is going to break down a little bit, but it's probably just a temporary breakdown. Anyway, this is a long video, I know, but a lot to talk about it, and I thought it was an excellent case to be instructive and to show you how to look at coastal storms as you go into the winter. Most of my videos in the future are not going to be this long when we get to East Coast winter storms, but it's one of the things I specialize in. I've worked on it a long time. I've done a lot of studying with a lot of people about it. I know these storms like the back of my hand, and hopefully this was instructive and you found this useful. This is meteorologist DT from Weather Risk. I'll catch you over on the Facebook page and on the Twitter page.